what does interpretability mean in this context? So by interpretability, I mean that after we have trained a deep learning model, we end up with a multi-layered network, and we have a bunch of weights. And so, for example, we're getting something, we might be getting some specific thing always wrong, and we want to see why that's happening. It would be hard to realize, to find out what has actually gone wrong, because we can't really interpret how that multi-layered neural network is working. Whereas in the traditional methods, you can pick up a part of the algorithm and say, okay, here, for example, here you're lifting something wrong, or here in this type analysis pass, you have a bug, so you infer the wrong type. But with the machine learning, with the deep learning method, this is not easy to do. You just have a bunch of weights, and it's not easy to see what parts are related to which weights in the model. And it's also not easy, even if you find out, okay, these weights are wrong, it's not clear how you can fix them because you have just some numbers for those weights. And another question is, have you considered compilation without the linking stage in order to be compiled? Is the large code base that is real world application without having? Yeah, this is a good question. So for the, especially for the large C data set that we wanted to generate, we used Debian packages. And so what we were basically doing, first of all, the input, we're not inputting raw bytes of the binary here. We do the compilation. So the way we did it was the Debian packages, you can have, they kind of have their own recipe with them that builds the package. And then during that stage, there are multiple stages to that. And one of the stages, .s files for the assemblies are generated. Some of these go to the temporary directory and are removed at the end. We hooked up the unlinked syscall so that those are not removed. And we directly use those .s files. So we didn't go until, this is what this thing that you mentioned is actually something that we use. We didn't use the final executable. We did the intermediary step and looked into the .s files so that we don't have to deal with the linking part. Is there any other question?
Yes, Iman, I just have one, not exactly a question, but rather a comment. Have you tested your model to transpile, like use it as a source-to-source compiler?
This is something I did consider and think about. One of the issues with that, there's actually, so one thing is that I did think about trying to do transfer learning so that I keep some of the weights that were trained like this and then have a model with these part of these, basically reusing the weights that I had for C and Golang, and then make a new model with the newer hidden layers. But based on the attempts I made in terms of doing this in this way, it wasn't looking promising. But I think another way that you mean by your question is that you have a C model and you have a Go model. What if you apply the Go model, but on the C binaries? And again, this is also problematic because the dictionary, so in terms, because there are different models for each language, there are also different tokenizer for the different assemblies. So for example, in OCaml, you see you might be seeing some instructions that you would usually not see with the C compiler or the Fortran compiler. So this is one of the issues that make this hard to do. The dictionaries are just so different that transpilation becomes hard for the model. It can't do the transpilation.